Hello, welcome back. In this module, we're going to be talking about t-tests. Now, there are lots of different t-tests that you can run in different situations. The general assumptions of the first t-test that we're going to look at using the math is that the two groups that you are looking at, so the two group values that you're viewing, in our case male and female, are independent, that they are not the same people collecting them, so you can have like different time points or something. That's a different t-test. So the groups need to be independent. We need a normal distribution of our data, and the variance across participants on the DV needs to be the same. So it needs to variance needs to be equal. There needs to be homoscedasticity, and of course the dependent variable needs to be continuous. So there are lots of different t-tests that you can run to help you adapt to violations of some of these assumptions. There's a different t-test if you have unequal variance between your groups. There's a different t-test if you have unequal members of your groups. But we're, for the math anyway, we're going to focus just entirely on the independent samples t-test. When we get into SPSS, we'll look at some of the different variations of t-tests and how they're used. So here I've set up a little bit of a spreadsheet for us to work with. I've got men and women and their scores on the acceptance of political violence scale thrown in here. So as you can see, we had 43 men in the sample and 53 women. All their scores for the political violence scale are here. I've calculated the mean for the women and the mean for the men, as well as the standard deviation between the two. So notice we have an N of 96, and this is the formula for the independent samples t-test. It is basically, the formula for the t-test is the difference in the means divided by the variance in the groups. So it takes into account the very center of the groups. If you imagine that X on the diagram that we looked at in the last module looks in the difference of values in the means, and it also takes into account the variance, the spread of dots around the mean. So if you can imagine all the dots above and below the X on our little diagram, that's what this takes into account. So this bottom part here, this is the formula for the standard pooled variance, so standard deviation sub x1, x2, and that is the square root of 1/2 times the standard the variance of x1 plus the variance of x2. We have the standard deviation here. If you'll recall, the variance is just the standard deviation squared. And I've put that formula in here. Oh, I forgot to square our standard deviations, so just do that real quick. That changes it just a tiny bit. So that is the pooled variance. Then I've calculated the t-test here using the pooled variance and the means that we already have calculated. Now our degrees of freedom for this particular test are N minus 1. So our degree of freedom would be 95. And I do believe if you look that up on a critical t-value table, then that would show that we have a significant difference among the means, which makes sense because the difference is quite large. So that is a quick down and dirty overview of one type of t-test and some of the assumptions of t-tests in general. In SPSS in the next module, we're going to look at a lot more t-tests and I'll show you how to run all of them. So I will see you in the next one.